Hey guys, today we're going to discuss complex numbers. So here's some notes that you can use to learn complex numbers. So the goal for today is to write, graph, and operate with complex numbers. So let's move forward. Real numbers. Real numbers, examples of real numbers are like, let's say 2, -7, 1/2, square root of 25. All these numbers are real numbers. So if all those are real, what's left over? Well, you have imaginary numbers. Okay. So when we deal with imaginary numbers, that's when we get into the idea of complex numbers. Complex numbers include a real part and an imaginary part. The imaginary part is I, and I is equal to the square root of -1. So you get this statement or this conclusion from that. If I equals the square root of -1, therefore I squared must be -1. Now this right here, let me highlight this. This right here is going to be very important later in the lesson. Okay, I squared being equal to -1 is going to be very, very important. So what can it do? Well, we use it when we need to take the square root or even root of a negative. Okay, so when we have to take the square root of a negative, we're going to throw in an I. So let's look at an example where this happens. It tells me to simplify square root of -4. Now the first time I work this, you're going to see me put in a lot of detail, and I won't put as much detail later. This, I'm going to think of this as the square root of 4 times -1. I can split that up into two separate square roots. This is going to be the square root of 4 times the square root of -1. And the square root of 4, you should know that to be 2. And we just said a second ago that I is the square root of -1. So here, I'm going to say that this is 2 times I. And then finally, I'll just write that as 2I. So that's how we can use it to simplify negative square roots. Looking at this example, same thing. I'm going to think of this as square root of 5 times -1. Square root of 5 does not simplify, so that's just going to be square root of 5. And the square root of -1 is going to come out to be I. So this is square root of 5 times I, which you will see written in a textbook as I on the square root of 5. So that is how we can simplify square roots. Last example, I have to simplify this square root because this is not a perfect square. So I'm going to do a couple different things. Number one, this negative right here is going to tell me that I have to throw in an I, and then I'm going to break down 24. So that's 2 and 12, that's 2 and 6, and that's 2 and 3. Oh, that's not a 3. Let me erase that. 2 and 3. So since this is a square root, I'm going to look for pairs. So there's a pair of 2's, and no more pairs. 24 breaks down into 2 on the outside, square root of 6 left on the inside. If you're wondering about the 2 and the 6, this pair of 2's right here makes 1 2 on the outside. And this 2 and 3 right here, 2 times 3 is 6. It stays on the inside. The reason I left this white space in here, the reason I left this white space right here is because this negative is going to turn into an I, so I'm going to put an I right here. So the square root of 24, or -24, is 2I square root of 6. Next example, square root of 63. Same thing, this is going to get me an I. I'm going to try to break this down. This is 7 times 9, and 9 is 3 times 3. So here's a pair of 3's, so that gets me a 3 on the outside. I need an I on the outside for the negative, and the only thing left over is the 7, so I'm going to put a 7 on the inside. So square root of -63 gets me 3i square root of 7. We can also use it in other situations. Let's say we were squaring this right here. If you don't forget that when you're squaring something, it means to multiply it twice. So what I like to do is scratch this out and write it a second time. So I'm going to do I times I, and that gets me I squared. And then I'm going to do square root of 3 times square root of 3, and that gets me square root of 9. Now I squared, let's go back a few slides. I told you here in a second that I squared equals -1 is going to be important, and it is right here. So let's go back. I squared is nothing more than -1, and square root of 9 is nothing more than 3. And I'm putting in parentheses just to show multiplication. So -1 times 3 is going to be -3. Okay? So be prepared when you see an I squared to change it into a -1. Now let's solve this quadratic. Notice in this quadratic I don't have an x term, so I can't factor this like we did a week or two ago. So what I'm going to do is I'm basically going to isolate the x squared by subtracting 10. So that's going to get me 3x squared equals -36. I'm going to divide both sides by 3. And so x squared comes out to be -12. So I'm going to take the square root of both sides. So x equals the square root of -12. And you'll see we're in a similar situation to what we're in, let's say, on this example. I'm going to break down the 12, and the negative is going to get me an I. So basically the same skill I used here, I'm going to use here. We'll try to break down the 12. That's going to get me 2 times 6. That's going to get me 2 times 3. So there's a pair of 2's right here. So like I said, the negative gets me an I. The pair of 2's gets me a 2. And the only thing left behind inside the square root is a 3. So this is 2i square root of 3. And to be clear, I should put plus minus because I took the square root when solving. So I have to have two solutions. So I have plus minus 2i square root of 3. So to make this more exact, I should put a plus minus right here. Alright, let's solve this equation. The first thing I need to do is I need to get rid of this -1/2. So I'm going to multiply both sides by -2. That's going to cancel out this -1/2. So I end up with x plus 1 squared equals -10. I'm going to take the square root of both sides. So this is going to get me x plus 1 equals plus minus the square root of -10. Now over here to the side, I'm going to simplify square root of -10. 10 is 2 times 5. So I don't have any pair of numbers when I prime factorize it. So the only thing I can do is I can change this negative into an I. So this is just going to get me I on the square root of 10. So x plus 1 equals plus minus I on the square root of 10. I know that might look like a 40 to you, but that's actually -10. So then I'm going to move the 1 over and make it negative. So x equals -1 plus minus I square root of -10. And there's the solution. Okay, so let's look at the next example. We've got 2x squared plus 26 equals -10. I'm going to subtract 26 from both sides. That's going to get me 2x squared equals -36. Then I'm going to divide both sides by 2. That's going to get me x squared equals -18. Take the square root of both sides. Don't forget your plus minus here of -18. Now over here, let's work on negative 18. The negative is going to get us an I, so we know that much. So let's break down 18. That's 2 times 9, and that's 3 times 3. So I have a pair of 3's here. So the square root of negative 18 is going to equal out to be 3i on the square root of 2. X is going to equal plus minus 3i on the square root of 2. So that's how we can use I when we're solving quadratics. Back to the idea of complex numbers, there's a standard form that you should know, and there's a real part and an imaginary part. And the real part goes first, and the imaginary part goes second. So if we go back a couple of slides, you can see here's the real part. Negative 1 is a real number, plus the imaginary part, you can see the I. So this is standard form of a complex number. They won't always have square roots in them, like this example here, 6 plus 2i. Notice it doesn't have a square root anywhere in it. So let's see what we can do with this. Okay, so we can graph each of these. So we can graph complex numbers, and it's not very difficult. Basically, this is going to be your x-coordinate, and this is going to be your y-coordinate. So, for instance, negative 2 plus 5i, I'm going to go left 2 spaces, and then I'm going to go up 5. 1, 2, 3, 4, 5. So that's negative 2 plus 5i, 2 plus 2i. My next example, I'll go right 2 spaces, and then up 2 spaces. Then I have 4 minus 3i, so I'll go right 4 spaces, 2, 3, and 4. Then I'll go down 3, 1, 2, 3. That's 4 minus 3i. And the last one is negative 4 minus 3i. So I'm going to go left 4 spaces, 1, 2, 3, 4. Down 3 spaces, 1, 2, 3 spaces. So that's negative 4 minus 3i. So that's how you would graph a complex number. Shouldn't be any more difficult than that. You can also add and subtract these, so we're going to treat them as like terms. You can use a calculator on this, and I'll show you. So since this is addition, I'm going to basically just drop all my parentheses. So negative 1 plus 2i plus 3 plus 3i. Now, negative 1 plus 3 is 2. So negative 1 plus 3 is 2. And then 2i plus 3i is 5i. Okay, we can also do that with the calculator, so let me get that pulled up and I'll show you how. You have to go into the mode and tell it that you want it to do complex numbers. So we got to go down here, switch this over and hit enter. Now the calculator will work with complex numbers. So I'm going to type in what I had in my smart notebook, which was negative 1 plus 2i plus 3 plus 3i. So if I scoot this over, I can see both at the same time. And I'm going to type in negative 1 plus 2i. And I've got to remember where I is. I don't believe there's a shortcut on my... yes, it is, down here on the bottom. Second decimal point will get me an I. Close, plus, open, 3 plus 3i. And I get 2 plus 5i, just like I got a second ago. So you can see, so long as you set your mode up correctly, you can use a calculator to solve these. Now, let's go to the next example. Okay, so I'm just going to go straight to my calculator on this one. I have 2i minus, open parentheses, 3 plus I, close parentheses, plus, open, 2 minus 3i. So this should come out to be negative 1 minus 2i. So I better get, I I better get negative 1 minus 2i. So I'm going to work through this just to make sure. This minus sign means I have to distribute the negative when I drop my parentheses. So I'll have 2i minus 3 minus I plus 2 minus 3i. Let's take care of the real part first. Negative 3 plus 2. Negative 3 plus 2 is going to get me negative 1. And then 2 minus 1 is 1. 1 minus 3 is negative 2. So I do get negative 1 minus 2i. Let's look at the next example. You can multiply with this also. We've been adding and subtracting, but this is multiplication now. So I'm going to distribute the I and treat it like it's a variable. So I'll have 3 times negative I is going to be negative 3i. And then negative I times positive I is going to be minus I squared. Now, I have to remember from several slides ago that I squared equals negative 1. So this is going to give me negative 3i minus a negative 1. And hopefully you remember that when we subtract a negative, we're adding. So this is going to be negative 3i plus 1. Switch this around, so my real part's first, and I get 1 minus 3i. So let's throw this in our calculator, make sure we get something that agrees. We'll clear that out. I'll have negative I open parentheses 3 plus I, and I get 1 minus 3i, so I did that correctly. Awesome. Okay, last example, we're going to do double distribution. And this is where a calculator can really help out, just because it speeds up so much of the process. But I'll remind you that double distribution, I have to do this term times both of these. And then I have to do this term times both of these. Okay, so I'm going to do that. 2 times negative 6 is negative 12. 2 times negative 2i is negative 4i. 3 times negative 6 is going to get me negative 18i. And 3 times negative 2 is going to get me negative 6i squared. Most students miss the I squared here. That's going to matter later because I squared is negative 1. So simplifying what I can, negative 12, negative 4 minus 8 is going to get me negative 12i. And then this is going to get me negative 6 times negative 1. So that's negative 12 minus 12i. This is going to get me plus 6. So these two real parts can go together. And I'll get negative 6 minus 12i. So let's throw up my calculator and double check myself. Clear that out. I'll have 2 plus 3i times negative 6 minus 2i. And I get negative 6 minus 22i. So I have messed something up somewhere. 2 plus 3i, negative 6 minus 2i. Let me go back and double check all my math. 2 times 6 is negative 12. 2 times 2 is negative 4. 3 times 6 is negative 18. Aha! That should be 18, not 8. So when I do negative 4 minus negative 18, I get negative 22, which just continues on down. So I end up with negative 6 minus 22i. So, glad I used my calculator to check myself, but make sure when that happens, you always go back and find your mistake. You can't always trust your calculator, and you can't always trust yourself. So you should always make sure that the two of you agree. But that is how you work with complex numbers. I showed you how to simplify radicals. I showed you how to solve quadratics. I showed you how to graph them, add them, and multiply them. So I've got some practice work in Canvas that I would like you to complete today, and that should be it.